Thank you very much. So in terms of the whole track, data as a service, I think we've got a really big problem to solve. I tweeted about it just before. I think that innovation is an accelerating force which is pulling the whole world into chaos. Talk about how we're going to solve it. I was at a function last night and I heard a couple of executives from Amazon and a VC manager having a conversation about when they got into IT. And as those conversations usually start, one person was talking about punch cards, someone else was talking about assembly language. And although I didn't sort of interrupt them, I kind of wanted to say to them, well, I've been in IT since 1972. 1972, 73, depending on how you look at it. I was born on the 3rd of February, and so the way that I think about myself as being in IT is that I was 3D printed through a runtime execution program over about 9 months, a thing that is separate from a society or a people. We live with it. It's just an innovation that's come with us. So when I say that innovation is an accelerating force pulling us into chaos, it comes from the concept of knowledge. Knowledge is something which we live with, and it informs us and it creates wisdom in the way that we live our lives. But working backwards from knowledge, it comes from extracting discrete, understandable facts over time and forming a narrative that you can quality check over and over and again in an iterative process. So when I talk about data as a service, what I want to think about data as is our savior. It's going to stop us from being pulled into the chaos of innovation. Data itself is entropic, which means that it goes into a more unstable state unless you cool it down a little bit. And I think that data as a service is a process of cooling down that entropy, trying to channel data or even create data so that you can have some manageable strategies around it. Through that, you can then provide it as a service, and it has immense value for people, particularly when they're facing oblivion. So, I have some slides. So, as mentioned, I have many hats. The three things I was going to talk about, really, there's the economics of data. The reason I had that little monologue at the start is because economics is based on, rational people making decisions, and over that sort of process, how can you model things into the future? So how can you have a more sophisticated example of how the world will work in a particular system? Information is a particular kind of good in economic terms. It's the type of good that doesn't diminish value if it's shared. So whilst everyone can enjoy swimming in a pool, the more people who jump into the pool, over time you'll have a diminishing sense of value because you'll be cramped. You won't have any excitement. And we've seen some pools in China that have masses amount of people, and I don't know how anyone has any fun time there. But, for the first couple of hundred people, they're having a great time. So information doesn't diminish in value for any individual as it's shared. And that's why it's really special. Wikipedia is an example of how knowledge can be created from information, co-created through collaboration, and it is also a good example of a public data, public open data construct, which has pulled some chaos into a more controlled state and given us a very valuable outcome. In economic terms, when we're looking at organizations and the theory of the firm, why we have big conferences like this is because it's more efficient to form the social contract of everyone coming together and discussing certain topics if you were to have a place for them to do that. Organizations do the same thing when it comes to heating and cooling staff and providing desks and computers and places where they can be productive. But more and more technology is breaking down the need for such devices to provide collaboration, and what we call transaction costs can sometimes be cheaper if you form a contract with an external party to provide the service that you would otherwise do inside your organization. This has a lot of impact on government in particular because there's no reason to have good big government if you can have good smaller government. You can reduce budgets. When it comes to government and security and classification, there's a very good reason why those things exist. It's because governments are formed through consensus. They come into being through things like constitutional artifacts, which then govern the way in which things like legislative and administrative acts are formed which then inform further precipitation of delegation into things like agencies and ministries and programs and outcomes. When all of those things map through into a social construct like a jurisdiction, a place, a city, the lines of delegation do not intermix, so the silos start to appear. The kind of things that we do to classify data are usually mapped back to those silos and the reasons why there are those separations. So we look for things like, are there personal records in data? Does it contain confidential information? There's a whole list of them there, and confidential information must be important because I repeated it at the end. The types of network security that you can put in place are pretty easy to do technically. We use CCAN, my company uses a lot of CCAN to show that data that has been classified as being released into that space. This diagram, although pretty, is basically just a simplified version of what we've done for the Victorian government. Agencies have their own CCANs or their own information management systems. The whole of Victorian government has a CCAN instance so that public sector can look at all data assets. And then the open data portal for Victoria also has a CCAN instance, so anyone in the state or indeed the country or world can see the data. We do this on Amazon because infrastructure is software. It used to be that there were these silos, these segmented pieces of a puzzle that you had to put together, and you had to use different methods to put them together. But now storage, network, compute, and software, you can use the same tools to put them all together. We recently completed a project to build supercomputer clusters on Amazon, and we published our orchestration scripts as open source on GitHub because we see the work that we do as publicly valuable and that we should be sharing it. And there's no difference that those orchestration scripts aren't actually code for a web application or a JavaScript library. Not all problems can be solved with IT, and in fact, in majority of cases, it's a non-IT problem that we're solving. It's just that we look at the IT as the enabler for the solution. So this is a diagram produced by Dr. Rufus Pollock from Open Knowledge Foundation internationally, and it's just charts on the x-axis where some things are solved by IT, and on the y-axis where some things are actually other factors, institutional factors, change management. Pia in the earlier session today was talking about things like literacy and leadership as being key ingredients, not just the technical infrastructure. Open government comes from the heart of open source. The principles of open source are openness, participation, and collaboration. The principles of open government are transparency, participation, and collaboration. And this is the path of innovation. This is the way in which innovation is currently being manifested in all walks of life. Collaboration is the key one when it comes to economic drivers. Within government, we support civil society. Most constitutional artifacts are usually driven by civil unrest. So if we didn't come together as a people and all agree on one thing, if we didn't manifest that in a document or a charter by which we can live our lives, we'd have a lot of trouble. We wouldn't have anything to back reference to. But in supporting civil society and all those programs and ministries and outcomes and projects that we do, all we really need to do is provide the essential infrastructure. If no one was beating each other up or stealing their things from people, we wouldn't need a police force. If nothing was burning, we wouldn't need a fire department. Some of the projects that we've been working on with my company are trying to blend together these notions. The public sector and the private sector are sort of the same thing. How do we get trust into the community and private sector? Well, you have to reach into the public sector. You have to work hard. You have to take responsibility and show that you're worthy of public sector trust. So working for the ACT government, we pulled together a platform based on Amazon, Drupal and CCAN to build what we call the Canberra Public Image and Video Library. The notion is to create an online space not dissimilar to physical libraries, which can hold the image and video assets for all of Canberra, and try and create a little bit more control around the chaos that's occurring with people capturing images and posting them on Flickr and Twitter and everywhere else, and help the city market itself as a destination, because it is a beautiful city. So we have a public facade we have CCAN as a data catalog which has about 120 assets in it, 120,000 assets in it. And we built an infrastructure which harvests from places like Twitter via hashtags, and the hashtags then feed directly into a data set. That supports things like event managers within the ACT so that they can create an event, create a hashtag, and then automatically ingest that into a data set that can be referenced thereafter, not just by them, but by anyone in the community. We also integrate with Flickr pools, acknowledging that there's a lot of community effort that people have already put into collating their own imagery and curating it and putting it online. And because CCAN handles licensing quite well, we can back reference to the originating licenses for all of these and make them directly referenceable, machine-readably referenceable, so that misuse can be identified. Perhaps the most exciting thing, actually, in the last month is working on data pipelines. So as an ex-programmer, now that I don't have time to program so much, there's sort of 4 ways we build things. You can build a script which has a bit of data, has a bit of code, and you get some knowledge out of it for use for your own self, for your own sort of building of understanding. Or you might want to communicate that to someone. So you tend to do something more like a live workbook, which has a title, a bit of text, a bit of data, a bit of code, an output such as a chart, a graph, and then your own analysis or interpretation of it. And that's then put out publicly for other people to see, to understand your point of reference, your respective understanding of a situation. More recently, we see people doing active applications. So there's a data set that underlies something like the Singaporean 2015 budget. Data journalists build an application which allow people to drill into it, facet search it, change the inputs. Those sorts of things are also very interesting. But live documents is a concept that I'm pretty keen on at the moment, because if you're a large agency doing some really important work on biodiversity within a geographic region and you have to do a sustainability report that requires 20 data scientists across a very large space to pull together sensor data from water temperatures to vegetation states to soil erosion states to everything that's going on, petitions for industry development within that region, that data itself is intrinsically very, very important to your work. And if you're going to create some analysis on top of it and say that we're going okay, you need to have that in a defensible state. You need to be able to have your insights backed up by the data, but also importantly backed up by the code that you used to produce the insights, the figures, the charts and everything like that. So this work has actually been done in Western Australia by Florian Mayer. He's a great developer working with CCAN. It's the WA Parks and Wildlife, and they've created this data pipeline which uses RStudio, uses applications which the data scientists are familiar with, publishes artifacts into CCAN, and then at the end of the day they're able to run a very simple script that pulls all the disparate data sources together with all the figures that have been generated and pull it into a PDF document to provide as a report to the Minister, table in Parliament, and what used to be a very, very large project became very simple. But importantly, in that document, below the figure, there's a hypertext link. You click on that link and it takes you to CCAN and it shows you the data set. So anyone in the community can check the work. They can also see the code that was run to create the figure. They can also see the figure. Community is a big part of all this. And in Australia, I'll just quickly run through some things. We have a hackathon with about 2,000 contributors to it that's run every year, 30 cities. We have transformation activity going on globally. So the Digital Transformation Office in Australia has been recently formed. Pia Waugh, who was speaking earlier, took an 8-month secondment into that area. Where it comes down to what kinds of services you can do with data at the moment, I think it breaks down to these sorts of things. If you study business and look at profit models, you can kind of identify that there's specialist services, managed services, and product integrations. This is how my company operates in terms of how we create and monetize. These are the sorts of projects we do for data pipelines and ingesting from agencies into jurisdictional portals. This is just an example. We actually manage and host the Data.gov.au portal, as well as the New South Wales, Victoria and South Australian portals, and Brisbane City Council. And there's lots of work out there. If anyone's working on this stuff, you can do extract, transform and load scripts. You can do data cleansing. You can do geospatial integration. You can build resource views in CCAN to create more insight. You can, in the future, I think, use a lot of machine learning modules to create more insights on top of the fundamental data. And this is the problem we're solving, that subjectively we create knowledge with the intention that someone at the other end of seeing your artifact will understand your thinking. Machines don't understand that. Semantically, they're not the same as us. So we need to build data on top of a service that provides the data itself, the schema, and an API so that applications can operate independently. That's me.